Hello friends and dear students. This video lecture is prepared with an objective to make the listeners understand the basics of conduction. What is heat? Heat is a form of energy that can be transferred from one system to another as a result of temperature difference, or simply we can define heat is thermal energy in transit due to temperature difference. So heat is a form of energy that will be always in motion, moving from one place to another place. When the same energy is stored in the system, we use the term called as internal energy. What is heat transfer? The science that deals with the determination of rates of such energy transfer is called heat transfer. Rates means the time taken for energy transfer. Why heat transfer? We are concerned about the rate of heat transfer rather than the amount of heat transferred in most of the practical cases. For example, the person who designs a thermoflask can calculate the amount of heat transferred by hot coffee to cool down from 90 to 80 degrees Celsius by using thermodynamic analysis. But he will be interested in knowing how much time does hot coffee takes in order to cool down from 90 to 80 degrees Celsius. This can be determined only using heat transfer analysis. So whenever the amount of heat transfer has to be calculated, then we should go for thermodynamic analysis. And if we are interested in knowing how much time does the heating or cooling process take place, then we have to go for heat transfer analysis. Modes of heat transfer. Whenever there is temperature difference in a medium or between any two mediums, heat transfer can occur by means of following mechanisms, mainly conduction, convection, and radiation. So this modes of heat transfer is otherwise called as heat transfer mechanisms, means of heat transfer, different types of heat transfer likewise. What is conduction? When temperature gradient exists in a stationary medium, which may be a solid or a fluid, we use the term conduction to refer the heat transfer that will occur across the medium. Conduction may be viewed as the transfer of energy from more energetic to less energetic particles of the substance due to interaction between the particles. Conduction in solids. Suppose if you consider this to be a solid medium which is heated at this end. This is the hot end and this is the cool end. As this end is heated up, what happens to the molecules is they become excited and they'll start vibrating. When one molecule vibrates, the other molecule which is bonded with this also starts vibrating. Likewise, the vibration or the disturbance is carried from this hot end to this cold end. This is otherwise called as lattice vibration. Also, there will be flow of free electrons from this end to that end, which is also carrying energy. So totally in solids, these are the two main causes, that is lattice vibration and flow of free electrons, that are responsible for carrying the energy from hot end to cold end. In liquids, the molecules are comparatively very loosely packed. So what happens if this end is heated up? The molecules will start moving randomly, that is, they will not have any definite path. This random movement is called as molecular diffusion. As and when the molecules move randomly, there is possibility of molecular collision. Two molecules will collide with each other and there will be energy transfer taking place, as we said, from more energetic particle to less energetic particle, the energy will be transferred, and likewise the energy will move from this place to this place. Same thing in the case of gases, only difference is the molecules are very loosely packed compared to that of liquids, and it happens by means of, that is, heat transfer happens by means of molecular collision and diffusion. So the main thing to be noted in conduction is it can occur in solids as well as in fluids, provided it should be a stationary medium. Examples of conduction. Here is a simple example of conduction. When you dip a metal spoon inside a hot coffee, you can feel the warmth of the hot coffee on the free end of the spoon within few seconds. This is why, because the heat of the coffee is being transferred through the metal spoon to the free end. So this is an example of heat conduction through solids. Similarly, on winter day, from a hot room, continuously heat will be escaping through the cold air outside. And this is because of heat conduction through the wall that separates the room air from the outside air. Now, it is possible to quantify the rate of heat conduction using Fourier's law of conduction. Fourier is a name of a scientist. He has experimentally proved that the rate of heat conduction through a medium will depend upon the geometry, thickness, material of the medium, and the temperature difference across the medium. Here is a plane wall considered. Consider steady state heat conduction is happening through this plane wall, which is denoted as Q dot. Simply Q is the amount of heat transfer, and if it is Q dot, it will be rate of heat conduction. The thickness of this wall is delta X, and the surface area of this wall on both the sides, it is A. As per Fourier's law of heat conduction, we can conclude that rate of heat conduction Q dot will be equal to minus Ka dt by dx watt, where K is the thermal conductivity of the material, that is the ability of the material to conduct heat. A is the surface area, which has nothing to do with this delta X. dt is the temperature difference, that is T2 minus T1, and dx is this thickness of the wall. dt by dx together, it is called as temperature gradient, which is the slope of this curve, Tx curve, at the location X. Negative sign is because the heat is transferred in the direction of decreasing temperature from T1 to T2. This is the direction of heat transfer in the direction of decreasing temperature. That is why this minus sign has been included. The unit is watt. Let us solve a simple numerical to understand this Fourier's law of heat conduction. The question is like this: the roof of an electrically heated home is 6 meter long, 8 meter wide, and 0.25 meter thick, and it's made of flat layer of concrete whose thermal conductivity K is equal to 0.8 watt per meter degree Celsius. The layer of the inner and outer surface of the roof one night are measured to be 15 and 4 degrees Celsius respectively for a period of 10 hours. Determine the rate of heat loss to the roof that night and the cost that heat loss to the homeowner if the cost of electricity is 0.08 per kilowatt hour. The assumptions here to be considered are 15 degrees Celsius and 4 degrees Celsius, that is the inner room temperature and outer ambient temperature are steady, means it does not change with respect to time, and the thermal conductivity of the roof, that is 0.8 watt per meter degree Celsius, which is the property of temperature, that is when the temperature changes, the thermal conductivity of the material also will change. But here for 10 hours period, we are considering this thermal conductivity also to be constant with respect to time. Okay, these are the assumptions. So how to calculate the rate of heat conduction? So by using this Fourier's law of heat conduction. Okay, it's Ka T1 minus T2 by L. dt, as said earlier, it is T2 minus T1, but here the minus sign is removed and here it is put as T1 minus T2. And this L is the thickness of the roof, which is already given as 0.25 meter. K is thermal conductivity and A is area, which is 6 into 8. So substituting all the values, we get 1.69 kilowatt. Now we have to calculate what is the loss for the homeowner because of this heat loss. So 1.69 kilowatt is the rate of heat conduction. So for 10 hours period, what is the amount of heat loss? It is 1.69 into 10, that is 16.9 kilowatt hour, and it is 0.08 per kilowatt hour, and for 16.9 kilowatt hour it is $1.35. So for 10 hours the loss for the homeowner is $1.35. And remember, all these calculations we have considered as heat loss only through the roof, but actually the loss will be more than $1.35 because through the side walls also the heat transfer will take place, and we have not considered these calculations in our problem. Okay, so this is how the rate of heat conduction is calculated. So in this small video lecture we have learnt what is conduction and how Fourier's law of heat conduction can be used in order to quantify the rate of heat conduction. Hope you must have understood. Thank you.